Welcome to Daily Papers, the podcast where we break down fascinating new research papers. Today we're talking about a future where AI does science for us. Imagine an AI co-scientist that can work 24/7, running experiments, analyzing data, and even coming up with new ideas.
It sounds like a dream for any researcher, but today's paper asks a really important question. What happens when this brilliant AI assistant is also a little bit unreliable and maybe a bit of a slob in the lab?
That's the core problem this paper, Confining Nondeterminism, tackles. AI tools, specifically large language models or LLMs, can already do a lot of research tasks, but the authors point out some huge flaws. The first one is trust. You just can't fully trust them.
Exactly. It's like having a lab partner who's a genius, but also a pathological liar. The paper gives some great examples. You can ask an AI agent the same question twice with no changes, and it will give you two completely different answers.
Or even worse, it might announce a breakthrough result, say that a new model achieved 94% accuracy, when in reality, it never even ran the experiment. It just made it up because it sounded plausible. This is what people sometimes call a hallucination.
And it's not just that they're untrustworthy, they're also incredibly wasteful. They're like that forgetful roommate who keeps buying milk because they can't remember if there's any in the fridge. The AI will rerun the same complex data processing it did yesterday, simply because it has no memory of doing it.
That burns through a ton of expensive computing power and the researchers' time because they have to constantly babysit the AI to make sure it's not redoing old work or going off on a useless tangent.
So the paper digs into the root cause of all this. Why are AIs like this? And the answer comes down to a single technical term that they want to solve: non-determinism.
Which is really just a fancy word for unpredictability. LLMs are designed to be creative and generate new, different text every time. That's fantastic if you want to write a poem or a story.
But it's absolutely terrible if you need to run a precise, repeatable scientific experiment. The paper says that every single step in an AI agent's process is what's called a stochastic LLM call. Stochastic is another word for random. So every time the AI thinks, it's essentially rolling the dice. We can't see its internal logic. We just see the unpredictable text it spits out.
Okay, so if the AI's very nature is the problem, how do you fix it? You can't just tell it to be less random.
You can't, and that's the beautiful central idea of this paper. Instead of trying to perform brain surgery on the AI, they say we should confine its randomness, put it in a box. And to do that, we should take a lesson from a piece of technology we all use and trust completely without a second thought: databases.
Databases? You mean like the software that runs Amazon's inventory or a bank's transaction records? How does that relate to a creative AI?
Think about it. You trust that when your bank's database says you have $100, you have $100. You don't have to watch its every move. That's because databases are built on a simple, powerful principle. They are deterministic.
Meaning they are predictable. If you add 10 to 90, the answer is always 100. It doesn't get creative and tell you the answer is roughly a blue-colored feeling of 101.
Precisely. The authors propose a system with two distinct layers, a two-stratum model. Let's call them the thinker and the doer to make it simple. The LLM, the creative but chaotic AI, is put in the role of the thinker.
And what does the thinker do?
Its only job is to propose a plan. A researcher can give it a high-level goal, like figure out if adding more data improves our model. The thinker can be creative, suggest ideas, and even write the computer code for the experiment. But, and this is the key, it is not allowed to do anything. It only writes the plan.
So it's the ideas department. Then who is the doer?
The doer is the database part. It's like a super meticulous, orderly lab assistant that is incapable of lying. It takes the plan written by the thinker and executes it, step by step. It keeps a perfect, unchangeable record of everything. Every piece of data it looked at, every line of code it ran, and every single result it produced.
And the most important rule, I'm guessing, is that the doer never, ever talks to the LLM. It just follows the plan and records what actually happened.
Exactly. The unpredictable, stochastic part is confined to the planning stage. The execution stage is totally deterministic and trustworthy. So, if the thinker writes a plan and then hallucinates a result of 94% accuracy, it doesn't matter. The doer will run the actual experiment, get a result of, say, 87%, and that 87% is what goes into the official record. The AI's claim is ignored. Only the executed result is saved.
And that solves the wastefulness problem too, right? If the AI suggests rerunning an old analysis, the doer, with its perfect memory, can just say, hang on, I've already done that. The result is X, and retrieve it instantly without redoing the work.
Yes, it gets all these guarantees. The paper calls them the 4 properties. It makes the research reliable because every result is backed by an actual execution. It's non-wasteful because work is never needlessly repeated. It's transparent because the entire research plan is a clear blueprint anyone can inspect.
And the fourth?
It becomes collaborative. The entire project, data, code, results, history, it's all neatly packaged in this database structure. You could hand it to a colleague, and they'd have everything they need to understand and build on your work without you having to explain a messy 6-month-long chat history with an AI.
So the big idea isn't to build a better AI, but to build a better system around the AI. You let the LLM be the creative, sometimes erratic brainstorming partner, but you put a boring, reliable database in charge of the lab notebook.
That's the vision. You confine the non-determinism, you put a fence around the chaos, and in doing so, you create an AI research assistant that is not just powerful, but one you can actually trust. A system that remembers what it did, proves what it found, and doesn't burn your money for no reason.
A truly fascinating approach to building the future of automated science.